Okay, we are actually on the experiment, which is a synthesis of a coordination compound, tetraamminecopper 2 sulfate. That's the experiment, and I have posted a video, so you can watch that video for the experiment. Now we are moving on to page 60, which is equilibrium studies. And on equilibrium studies, we are working from number 1 and going all the way down. We might skip a couple of parts, but we'll do most of it. So first thing you have to do is look at the copper sulfate pentahydrate. This is the color of copper sulfate pentahydrate. You'll see that it is a very, very distinctive blue color, and we call that turquoise blue. So make sure you use the right terminology. Copper sulfate pentahydrate is turquoise blue. And we took some of that here on the side. You don't see it, but I have this heated. So I put some in an evaporating dish and I heated the sample. So you should be able to clearly see the color of the heated sample, compare it to the color of the original, and write down the color of the heated sample. From that heated sample, I hope everybody can see that, and then I'm going to split that into 2 different test tubes. So basically, I'm just going to put a little bit here into one. Just shake it a little bit, and into one, and then I will put the rest into another one for the rest of the experiment. So again, color of the heated is very, very light, and you may want to record that color, compare it to the turquoise blue. All right, so we got number 1A and 1B done, and you need to think and write the formula. And then we are going to add some water to one of these test tubes. So let me grab that water bottle, which I forgot to grab here. So we are going to put a little DI water, and we are going to see that that's very, very close to the original color, which is a turquoise blue color. So okay, that's the one with water. You can record the color. Okay, and then to the other one, I'm going to put a little bit of ammonium hydroxide, which I have here. We shouldn't be using this outside the hood, but to video this, I need some here. So I'm going to put some ammonium hydroxide to my other sample. And once you know the color, I'm going to probably set this away from my nose. Look at that. That's a deep blue violet color. That should be what you saw by watching the video for the synthesis. All right, look at the difference between the 2 colors. This is the copper water, and this is the copper amine. All right, let's move on. Then I went ahead and made a solution of copper sulfate water. We are on number 3, and copper sulfate dissolved in water, which is a really light blue color. Let's move these out of the way, and let's put leave this right here. And let's move this. All right. So this is copper sulfate dissolved in water. They are just approximately same in the 2 tubes. I split them in half. To the first one, whichever one tube of that copper sulfate water solution, I'm going to work on 3A, which is I'm adding a solution of sodium hydroxide, which I have here on the side. You guys can't see it, but I want you to see what happens when we add sodium hydroxide. And I see some solid formation, and it looks like if you want to make jello at home. So the precipitate, it's a solid formation due to a chemical reaction. We have sodium hydroxide, and we have here the copper ions. So most likely the copper ions are reacting with the sodium hydroxide to form the copper hydroxide, so you can write a reaction for the copper hydroxide. It's a blue gelatinous precipitate. If you compare to this, it's slightly different. The color is a different blue. It's more like a chunky because it's a precipitate, it's solid. Okay, put that aside here. Now we are moving on to 3B. To the same solution of copper sulfate water, we are going to add some 6 molar ammonium hydroxide. So remember, this is a solution. Last time we added 6 molar ammonium hydroxide to the sample we heated. So this is a solution that we are adding the ammonium hydroxide to. So you add enough ammonium hydroxide to see a color change. And what do we see again here? That deep blue violet color as opposed to our original turquoise blue color. So this would be our copper amine complex, and you should be able to write the formula for the copper amine. Okay, and we are supposed to dilute this and heat this up, which I'm going to skip. So you should think that what happens when you heat it, you're going to remove the ammonia from the equilibrium reaction. So you have to refer to equilibrium reaction on page 55, the very last reaction. Ammonia will be removed when you heat, therefore lowering concentration of NH3 on the left side of the equilibrium. Therefore the equilibrium should shift to the left side. Therefore it should go to the copper water complex, which should give you a lighter blue color. So I'll let you figure that out, and I'm going to move to the last part, which is 3B with hydrochloric acid. So we have 3B here, and I'm going to add a little hydrochloric acid. Let me get that really quickly. Here's our hydrochloric acid. So we are going to add some hydrochloric acid to this test tube and see what happens here. Let's see what happens. Ooh. I should have used only a tiny bit of it. Maybe I should do that. Okay, beautiful. All right, look what we got here by adding hydrochloric acid. Beautiful green. So that would be the copper ions in this solution reacting with Cl- to form the copper chloride. Make sure you write a balanced equation for that. And there are a lot of equations you have to write. Make sure all these equations are balanced. When you're all done, your instructors will help you if you have questions. So hopefully we are good.